Hello everyone. In this lecture now we are going to see about the implementation of LDR sensor. LDR stands for light dependent resistor, and this is the resistor. For better view I am showing here. You can see this image, right? This is the actual resistor, that is nothing but LDR, and this complete part is known as LDR sensor. It is an analog sensor. So for reading its value, we are going to use the function analog read. Yeah, and here you can see that sensitivity adjuster. Similarly, you also observed in the IR sensor this part, right? For adjusting distance, I have mentioned there. Actually, this blue color box type part is known as potentiometer. It is present in some of the sensors for adjusting the values. And here you can see that there are three pins. Yeah, before that there are two LEDs similar to IR sensor. Power LED is common. Since IR sensor is for motion detection, there we have mentioned it as obstacle LED. And here it is called as D0 LED. D0 means don't assume it as a digital one. Actually, it is connected to the analog pin only because it is an analog sensor. And GND means ground. VCC we are going to connect to 5 volts. Now let us start programming. Yeah, first we are going to do without LED. Simply we are getting values, and based on those values now we'll operate the LED. Yes. Now let us consider pin mode. Pin mode is needed, and before pin mode we also need serial monitor to observe the values too. Serial dot serial dot begin. Serial dot begin of 9600. I am keeping the baud value. Pin mode of LDR, comma, input we are taking right from sensor, so mention it as input. Yes. Now coming to the loop, consider a integer variable. We are going to use analog read function. Analog read of what we are reading? LDR pin, right? So pass LDR. Yes. Now just we are going to print the value. Serial dot print of value. Let me give println to avoid confusion. We will also give delay. Yes. If no, let me show this if conditions afterwards. No need. Here only I will explain. Then I will explain with the hardware components. If value is less than 300, it indicates that serial dot println no need lights. Otherwise, lights are needed. On lights. Now next, we are going to give delay. Let me consider 2000 milliseconds, nothing but 2 seconds. Now just I am going to compile and execute it. Actually, after connecting the components, then only we need to do. But for showing just how the values based on that you are setting LED, for that I am showing first the output on serial monitor. Yes, you can see that on lights 1023. For 26, no need lights. Now again I am showing. Yes. for greater values indicates that there is more darkness, and once once there is a lighting near sensor, it indicates very less value. That's the reason I have mentioned for less than 300 no need to on lights, and for greater than or equal to 300 we need lights. Yes, you can see now on light message is displaying. This is how LDR works. Now I am going to show it hardware connection, and then we can see with LED also. Yes, you can see that my Arduino is connected, and now I am just going to connect only the LDR sensor. Here you can see that three pins are present. One is ground, one is D naught, red color wire is D naught, and I am connecting it to the analog pin A2 as per our program, and remaining two are VCC pin and ground pin. VCC, you can see that brown color wire, and that is connected to 5 volts, and ground is connected to ground, that is the purple color wire. Now you can just see that both the LEDs are on. And now just a second, let me open serial monitor. You can see 27, 28 no need lights, and here the light is on. The reason is that sensor, when the lights are not required in real application, then the lights on the sensor are on. We can alter our application, but we can't alter the sensors, right? That's the reason the on the sensor, nothing but this, if D naught is on, lights are not required. That here you can see with very less value, as there is so much lighting here, so that's why it is saying that no need lights. In middle you got messages that on lights. The reason is that now darkness came into the picture. Now here you can see, yes, when somewhat my hand shadow is coming, the D naught is off. And here you can see that the value is 1023 and on the lights. Now I am just removing my hand. You can see that D naught is on. Yeah, it takes time because we have given delay 2 seconds. So now you can see no need lights is being printed with very less value. With just a small shade, it is going to the value of thousands, and it is saying that on lights. Now so this is the implementation of analog sensor LDR with Arduino UNO. In next video we are going to see the implementation of LDR with LED, and for LDR there is no requirement of using buzzer in any sort of application. So I am just going to use LED for LDR.